see now what people understood from our code. So for this chapter, for this pile foundation design, we had two design examples, one from static pile load test, which was presented in detail by Patrick. So I will not present it again. You can see that it is the exact the same that Patrick presented, with the 9 piles resulting from this calculation based on static pile load test, the 4 test. So we received 8 solutions. I would make a comment saying that in general the number of the solutions received for all this benchmark exercise was very low. Those solutions came from France, Finland, 3 from Hungary, 1 from Spain, 1 UK, and 1 Slovakia. So you can see here the number of piles that resulted for everyone. It doesn't look bad, but as I was saying before to Christian, the devil is in the details. So we tried to look to the details of these solutions, and we found out, for instance, that for one of the solutions coming from France, they used a partial coefficient of 1.15, which was not correct, and I didn't understand exactly what this was coming from. Also for Hungary, one of the design examples from the solution of Hungary, they checked the resistance of pile group, and this was not mentioned, by the way, in the exercise, that we are looking for only the single pile bearing capacity, or considering only the single piles and without applying the group effect. And therefore they obtain more piles because the bearing capacity for the group is a little bit smaller. The second solution coming from Hungary, they used an old version of previous draft of part 3, and they used a partial coefficient of 1.35 instead of 1.1 multiplied by 1, the model factor for static pile load test. So this is showing that in this particular case, they mixed the method of design by testing with the method of design by calculation, by applying a coefficient that was not right in this case. Also, the third solution coming from Hungary, for this one they obtained 9 piles indeed, but they used partial coefficient of 1.2 instead of 1.1 multiplied by 1, the model factor. And also the solution from Slovakia didn't apply the right coefficient and the right method, and they used a partial coefficient of 1.4. So even though from the rounding the final results is not so bad and they are not so different, in fact, inside within the solution we can find different way to do it, and not all those ways are correct. So the main conclusion that we can have here is that it's not very clear for everyone which table should be used. As also Christian and Patrick mentioned, there are many tables with many coefficients, and each table is applying for a certain type of method or a design path, I would say. So it is not easy for the reader to find his or her way through all these tables. And also, depending on the national practice, I think that we will face some problems in understanding the different methods. As for example, I'm thinking to our design practice in Romania, we are using mainly prescriptive methods, and also calculation based of ground parameters. So I am expecting that maybe some of the other methods not to be so easily understood. I am keeping some other comments for the end of this presentation. So for the second exercise, the one design pile foundation design from profiles of ground test results, here we had 4 profiles of ground test results. And I put it here in red, that we assume that there are CPT values, but we didn't mention it. So this was my mistake. And I think both members of TGB2 who did originally this example and myself thought that CPT would be the obvious way to do it. But France, of course, supposed that there were 4 profiles of pressure meter, and the coefficients, of course, are different. So this was my mistake. We received here 9 solutions, 2 from France, 1 from Finland, 3 again from Hungary, 1 from Spain, 1 UK, and 1 Slovakia, so more or less the same as for the previous one. And here are the results, a little bit of scattered. TGB2 found 12 parts, as Patrick presented just some minutes ago. And then we have here 11, 12, 13, 15, 12, again 14, and here 10, 9, and 11. And let's take a look what happened here. As Patrick mentioned, while checking the coefficient of variation, this was 13%, so higher than 12. So because there were no other information provided, it was decided to split the data set into 2. Of course, there are no rules, and there are just assumptions that were made during the calculations. So TGB2 split it into 3 profiles, a cluster of 3 profiles, and 1 with CPT4 alone. So in France, they assumed 4 profiles altogether, and the partial coefficients were not those in the second generation of Eurocode 7, and they used some old design approaches from the current code. In Finland, they split it, but in 2 clusters of 2 profiles. This is why, but finally they obtained the same number of piles. In Hungary, the first solution, they didn't check the coefficient of variation at all, and therefore they took the correlation coefficient corresponding for 4 profiles, and also they again considered the pile group effect. So this is why they found more piles here. The second solution, coming from Hungary, used an old version of the draft code with different correlation factors, and again the partial coefficient of 1.35 for the compressive resistance, and they didn't check the coefficient of variation. The third solution, coming from Hungary, again they didn't check the coefficient of variation, and they used a partial coefficient of 1.2 according to the National Annex in Hungary, but this was the National Annex to the first generation of the code, because of course there is no National Annex yet for the proposal, the code of proposal. In Spain, they checked the coefficient of variation, and they split the data set into 2, but they used different partial coefficients. In UK, they checked the coefficient of variation, but probably they did a mistake because they obtained 11%, so therefore it was less than 12%, so they applied directly the coefficients in the table. In Slovakia, they didn't check the coefficient of variation, and they used the average value of the measured resistance divided by 1.4, which again was not correct. So the people are mixing all together those various tables and factors and so on. And the second solution, coming from France, they assumed that there were pressure meters, and it was an obvious conclusion for them, working usually with pressure meter. Therefore, they obtained 11 piles instead of 12. So this is the insight of each of those 9 solutions received. And again, we can see that it is not clear for everyone which table to use and which partial coefficients, which correlation coefficients, and so on. And again, depending of their national practice, there are different views of the final solution. And now I would like to comment a little bit, because it was also the discussion yesterday after I presented the results for the benchmark test for retaining structures. And I understood that also for spread foundation was almost the same discussion. First of all, you can see that we didn't have many solutions. So we discussed, and most probably we will decide to reopen it. We will see, because finally we would like to see how people is interpreting the code and apply it. And this will give us all a very good information about what is to be done at the national level, because we need to focus more and to explain more, and also to develop, if possible, not only a very good national annex and detailed one, but also some guidance document, because we cannot put every detail in the national annex or whatever technical norm we are using in our countries. Here I think we will have to discuss a lot in our countries with our designers in order to explain all this. And again, I'm thinking to Romania, and since we are applying mainly prescriptive methods and also design by calculation based on ground parameters, I am pretty sure that we will face some problems here. So we need to better explain. I don't know exactly if we still can do something at European level, and to, I don't know, providing a note, or not in the code, I mean, a separate document clarifying a little bit, or leaving this only to the national standardization body and the national committees to do it. We will discuss all this, but it's clear that things are not very straightforward all the time. And each country has its own practice, and they are designing according to it. So this is it, more or less, what I wanted to present you for this benchmarking, and please let me know if you have any questions.